All right, I want to take the antiderivative of this, and you know you have to have x to a power. So I'm going to invest time in separating around that addition in the numerator. So I'd have 1 over x squared plus root x over x squared. And again, let's spend some time making nice exponents, right? So that give me x to the negative 2. And then here I have x to the 1/2 and then x to the squared, so I'd have 2 minus 1/2 if I want to put it up in the numerator, which I do, right? So that gives me x to the negative 3/2. No, 5/2, because it's 2 minus 1/2, right? No, it's 3/2. Yeah, silly me. Okay. All right. So now, let's not forget, we want to keep this and the dx until I do the antiderivative. Okay, so taking the antiderivative of x to the negative 2 would be x to the negative 1 over negative 1 plus, add 1 to the exponent, x to the negative 1/2 over negative 1/2, just going slow. So let's fix this, right? Negative exponents are not pleasant to go plug numbers into. So this is the same thing as saying negative 1 over x, and this would flip up to be a minus 2, 1 over root x. Okay, now I'm ready to plug in the 1 and the 9. So if I plug in the 9, I get a negative 1/9 minus, this would give me 2/3, right? And then if I plugged in the 1, I'm just going to put it down here, subtract negative 1 minus 2. So it is what it is, right? Just kind of an ugly number. Both of those guys. Let's look at this one. So here, antiderivative of 1 over 1 plus x squared. You know that's arctangent. Yes, you do. And this one is arcsine. Yes. All right. So we know those antiderivatives. And now we're going to remind ourselves about the restricted domain when we go plug in these numbers. Okay. So I'm plugging in. So from negative 1 to 1. So let's just go plug them in, right? Okay, so I have arctangent of 1 plus arcsine of 1, right? That's plugging in the top limit. And then subtract off, plugging in the bottom limit, arctangent of negative 1. And then it's plus arcsine of negative 1. Okay. Arctangent and arcsine, they will continue to come up. So let's remind ourselves that they have this restricted domain. So you only can go up to pi over 2 or down to negative pi over 2. So just because of space, I'm just going to work upwards here. Okay, so arctangent of 1. What's the angle I can take the tangent of to get positive 1? Well, that would be positive pi over 4, right? And what's the angle I can take the sine of to get 1? Well, that would be pi over 2. So those are those two, right? And then I didn't really need parentheses there, but I'm just going to subtract. Let me just get rid of those parentheses if I can. Okay, I did need them. There, okay. So subtract. Now I do need parentheses here, right? Because I've got a subtraction. So arctangent of negative 1 is the angle that I take the tangent of to get negative 1. So that's negative pi over 4. And then arcsine of negative 1 is the angle that I can take the sine of to get negative 1. That's negative pi over 2. So these don't cancel, do they? So I'm just going to move up again. So I'd get pi over 4 plus pi over 2, and then I get a plus of pi over 4, and then plus of pi over 2. All those. All right, so here I'm just giving you more things to practice with. So we really do need to separate our integral around all these terms. Let's start with this one. So I'm going to say 1 to 2. So I'm going to have x squared over 2x squared minus x over 2x squared plus 2 over 2x squared dx. And so now I'm going to be really careful. So this is the same as just the number 1/2. This gives me 1/2, 1 over x. And this gives me 1 over x squared. Okay, antiderivative of a number, that gives me 1/2 x. Here, this gives me minus 1/2 ln of absolute value of x. And perhaps I could have rewritten this, right, to take the antiderivative of this. I could have talked about written it like this, so I get negative 1 over x. So 1 to 2, and then I go plug the numbers in. So that would give me 1 minus 1/2 ln of 2 minus 1/2. And then subtract 1/2, and then ln of 1 you know is 0 minus 1. So things kind of work out here, right? Let me just kind of finish this one off. So I would get a 1 plus a 1, right? That here, that would give me a 2. I'd carry this 1/2 ln of 2, and I'd get a negative 1/2 minus another negative 1/2, so that'd be minus 1. So look at that. So it turns out to be 1 minus 1/2 ln of 2. So I want you to remember, we know the antiderivative of 1 over x. We have to keep numbers off to the side. So this one here, I would even take the numbers off to the side. So you want to carry everything along while you're doing the simplification. So this is 2 times x to the negative 1/2, and then minus 3 over 4. And I like to leave the 1 over x like that. And that reminds me it's going to be ln. All right, so I'm ready to take the antiderivative, I think. So there's 2. And then I'm going to add 1 to the exponent of x to the negative 1/2. So that's x to the 1/2 over 1/2 minus 3/4 ln of absolute value of x between 4 and 8. So this turns into 4, right? Because I flipped that up. 4 root x minus 3/4 ln of x. Oops, and then still between, sorry, that's really messy. Still between 1 and 4. Okay, so now let's go, oops. Whoa, what did I just do? No, not 1 and 4, silly me. 4 and 8, right? Between 4 and 8. So let's go plug in 8 at first. So 4 root 8 minus 3/4 ln of 8, and you can throw away the absolute value bars once you see that it's positive. And then I'm going to have minus, I'm going to be substituting 4, so 4 root 4, that's 8, minus 3/4 ln of 4. Yeah, there's really not much you can do to simplify that. All right, let's go to this next one. Oh, I'll stop them and do it then in the next video.